Now coming to some more properties of hydrogen. When hydrogen reacts with water gas, what it happens? Water gas is carbon monoxide plus hydrogen equal volume. When hydrogen is reacting under it. Now it is not going to react under ordinary conditions, remember it. So it is going to react under, that is chromic oxide as a catalyst and zinc oxide as a promoter. We can say that chromic oxide and zinc oxide. The temperature is 350 degrees Celsius and 200 atm pressure. Under this condition, we can say it reacts. What is going to form? Now see here, how many carbon? 1 carbon. 4 hydrogen, 1 oxygen. It is going to form CH3OH, which is known as methanol. Alright, CH3OH is called as a methanol. Now, what if I, here methanol, it acts as nothing but an artificial petrol, we can say that. It is used to prepare, that is methanol. Clear? So in this way, we can prepare methanol in this manner. When water gas reacts with hydrogen under these conditions, it gives you methanol, we can say. Similarly, now when it reacts with metals, like the most electropositive metals or highly reactive metals like sodium, when it reacts with hydrogen, it forms what? Sodium hydride. So 2Na plus H2, 2NH. Now when it reacts with calcium, it forms calcium hydride, we can say that, CH2, we can say that. Potassium reacts with hydrogen to form what you can say? Potassium hydride. Lithium reacts with hydrogen to form what? Lithium hydride, LiH, we can say that. Clear? In this way, when it reacts with the most electropositive metals or the highly reactive metals, it forms the respective hydrides also is being produced, so to say. Now next is, it also helps in a reducing agent. It helps. For example, if you take copper oxide. Now here let me say you, I don't take sodium oxide, potassium oxide or aluminum oxide, because these oxides are the oxides of highly reactive metals, highly electropositive metals. So oxides of highly electropositive metals like sodium, potassium, calcium, aluminum, they cannot be reduced by ordinary reducing agent, that is hydrogen. They cannot be reduced by ordinary reducing agent hydrogen. Why? Because if at all it is reduced also, again it will react with oxygen to form the oxide. That means these metals, they have got strong affinity for oxygen. These metals have got strong affinity for oxygen. For that reason, it cannot be reduced by ordinary reducing agent, that is your hydrogen, it cannot be reduced. As I said, even if it is reduced, again it combines with oxygen which is present in the air to form back the respective oxide. So we have to reduce here, we will reduce here the metals which are having which are less reactive in nature, which are less electropositive in nature. Alright. So we will see copper oxide when it is reduced with hydrogen. So here hydrogen acts as a reducing agent. Remember that. Hydrogen acts as a reducing agent. It forms copper plus water. So in this reaction, hydrogen acts as a reducing agent. It reduces copper oxide to copper. It reduces copper oxide to copper, we can say that. And hydrogen gets oxidized to form water. Hydrogen gets oxidized to form water. Hydrogen acts as a reducing agent. Again I repeat. Suppose if I take here silver oxide plus hydrogen, if I take it, then what I will be getting? I will be getting silver plus, that is water, I will be getting it. So 2Ag plus H2O I will be getting. So in this way, when that is these particular oxides like silver oxide, mercuric oxide, copper oxide, when it is reduced, or cupric oxide, like this one is here, cupric oxide, we can also take cuprous oxide, any means metals which are lower in the metal activity series, which are less reactive in nature. So they can be reduced, got it, by using hydrogen, and this reaction is called as a reduction reaction, where hydrogen acts as a reducing agent. So you can see copper oxide is being reduced to copper, it loses oxygen. Silver oxide is reduced to silver, it loses oxygen, we can say that. Clear? So in this way, here that is silver oxide and copper oxide, they act as an oxidizing agent. When hydrogen will act as a reducing agent, because it reduces copper oxide to copper, silver oxide will act as an oxidizing agent. It oxidizes hydrogen to form water, so to say. In this way, altogether the reaction is called as a redox reaction. Altogether the reaction is a redox reaction, because here again I repeat, hydrogen reacts with oxygen to form water. Copper loses oxygen, and that hydrogen reacts with oxygen to form water. So here hydrogen is oxidized and copper oxide is reduced. I said it is a reduction reaction. Reduction of what? When hydrogen reduces copper oxide. But altogether, the total reaction is a redox reaction. Redox means when oxidation reduction takes place hand to hand together. That is said to be as a redox reaction. Oxidation reduction takes place together. We can say that. Now, in this way, we are having some more reactions of we can say that hydrogen, so to say. Now, let me rub it. Now here, when alkene reacts with hydrogen, alkene R CH double bond CH2. R is any alkyl group, so to say. So, in this, when alkene reacts with hydrogen plus carbon monoxide in presence of cobalt carbonyl. This is your cobalt and this is carbon monoxide. Cobalt carbonyl, it is said to be as, which acts as a catalyst, we can say that, under high temperature and pressure. High temperature and pressure. What is going to form? It is going to form, that is, R is there, then it will be CH3, then CHO. What is that? CH3, one hydrogen from here, it will be added to this CH3, and CH, that is O, or one more carbon is there, na? So one more carbon means R, CH2, then CH2 we can say, and then it is CH. Total how many carbon? 1, 2, 3. Here also 1, 2, 3 carbon. Total how many oxygen? 1 oxygen. How many hydrogen here? That is 3 and 2, 5 hydrogen. So it is 4, 1, 5 hydrogen. See, balanced in this way. So this is known as what? This is an aldehyde. It is another organic compound, aldehyde. We can say that. Clear? Now this aldehyde, again it reacts with hydrogen. That is R, CH2, CH2, then CHO. Again it reacts with hydrogen in presence of nickel and heated. Here nickel acts as a catalyst. Here nickel acts as a catalyst to form what? That is alcohol. R, CH2, CH2, then CH2, OH. It forms alcohol. This is an alcohol, we can say that. So aldehyde is reduced to alcohol. Here alkenes, it's reduced to aldehyde. Aldehyde is further reduced to, we can say, alcohol, we can say that. This is an alcohol. These are all organic compounds, we can say. And again I repeat, R is an alkyl group here, we can say that. So in this way, we can say that this is a reaction is been taking place with several other substances with hydrogen. Now coming to the nascent hydrogen, so to say. Nascent hydrogen is formed at the time of generation or the preparation of hydrogen. Nascent hydrogen means this one. Nascent. This is nascent hydrogen. And from where we get this nascent hydrogen? From reducing agent we get it. Reducing agent. For example, when zinc reacts with HCl, first this nascent hydrogen is produced. It reacts with another nascent hydrogen to go form H2. First this nascent hydrogen is produced, which reacts with another nascent hydrogen to form H2. H2 molecule is being done. But we are getting it. So when zinc granules, when reacts with HCl or dilute sulfuric acid, so to say. Clear? So in this way, a nascent hydrogen is generated, which reacts with further with nascent hydrogen to form what you can say a molecular hydrogen, we can say. And this nascent hydrogen, they are highly reactive in nature, because you know that hydrogen does not exist in the atomic state; it exists in the molecular state. So hence they are highly reactive. These are, and they helps in reduction. From where we get it? I said you already. We are getting it from the reducing agent. Like when zinc reacts with HCl, when zinc reacts with H2SO4, when sodium reacts in presence of alcohol. Got it? When zinc copper couple, zinc copper couple. Zinc copper couple means zinc and copper. This is called as zinc copper couple. We can say zinc and copper both are used, where copper acts as a catalyst. When it reacts in presence of alcohol, ethyl alcohol, it produces nascent hydrogen. So in this way nascent hydrogen is produced, and this nascent hydrogen is highly reactive because it is highly unstable in nature. Because you know that hydrogen does not exist in this state. It's highly reactive and it is used for the reduction purposes. For any reduction reaction, you can use molecular hydrogen. Here this is also reduction. But we can also carry out the reduction reaction by using a reducing agent. Alright, you will see in the organic chemistry or in the higher classes when you go, you will be finding out that reduction reaction can be carried out with molecular hydrogen also, can be carried out with nascent hydrogen also. So I said you from where we get nascent hydrogen. So whenever you are writing nascent hydrogen, in the arrow, that's over the arrow, you should write the reducing agent. Like zinc copper couple in pentyl alcohol, you can write from where it is being produced. Alright, this we write to show that from where this nascent hydrogen is produced, from where it is being produced. So over the arrow, you need to write that is the reducing agent. Either zinc copper couple in pentyl alcohol, or zinc slash dilute HCl, or zinc slash dilute H2SO4. Alright, or sodium in presence of ethyl alcohol, we can say that sodium in presence of alcohol. So in this way, any of the reducing agent you need to write it down. Alright, which will give you nascent, which will produce nascent hydrogen. It is a very reactive compared to the molecular hydrogen. It is much more reactive in nature, we can say that. Clear? And for particular reaction, particular what you can say nascent hydrogen is being used, so to say. Alright, and a particular reducing agent is used, so to say. Now, coming back to the uses of hydrogen. So hydrogen can be used as a fuel. It can be used as a fuel, like it is used to prepare the coal gas, the water gas, we can say that it is used as a fuel. It's a major component of the industrial fuel, we can say that. And just now I said you, that is we prepared methyl alcohol. So methyl alcohol, I said you, it can be used as a synthetic petrol, we can say that it is used as. Now it is also used as an oxyhydrogen torch, that is a mixture of hydrogen and oxygen when burnt in a specially designed apparatus. It produces a temperature of around 2500 degrees centigrade. It is used as an oxyhydrogen torch, we can say that. The oxyhydrogen torch is used for the cutting and welding of metals. It is used for cutting and welding of metals. It is used to prepare many compounds, like it is used to prepare ammonia, we have seen it. It is used to prepare hydrogen sulfide. It is used to prepare methyl alcohol. It is used to prepare fertilizers like CAN, we can say. CAN means that is calcium ammonium nitrate. CAN, C-A-N, all capital letter, C-A-N, CAN, which is calcium ammonium nitrate. It is used to prepare. That is a fertilizers it can be used. So it is used for the manufacture of fertilizers. It is used for the manufacture of explosives, we can say that. Clear? It is used for the hydrogenation of oils. Just I now explained you that is hydrogenation of oils. What you find is that the vanaspati oil or the soybean oil or the groundnut oil or the what I can say, it's the linseed oil, got it, or the cottonseed oil, we are taking it, which contains carbon-carbon double bond. They are said to be as polyunsaturated oil, which contains carbon-carbon double bond. I said you already that when this oil is kept for a long time, we are not using it, we are keeping for a long time. So what happens is that this carbon-carbon double bond gets oxidized to form either aldehyde or carboxylic acid, which gives a very bad smell, which is not fit for consumption, we can say that. That is, we say the oil becomes rancid. To prevent that, we convert it into vegetable ghee. That is, vegetable oil reacts with hydrogen in presence of nickel as a catalyst to convert it into vegetable ghee like dalda and all, I said it. So this process is called as a hydrogenation of oils. Next, hydrogen can be used for metallurgy purposes, like it can be used for reduction purposes, reduction of metals, like copper oxide reacts with hydrogen to give copper, silver hydroxide reacts with hydrogen to give silver in this way. That is used to extract the pure metals for the metallurgical purposes. It is used also for meteorological purposes, meteorological, for weather forecasting. That is hydrogen along with helium, we are using it. Got it? To fill up the weather forecasting balloons. Got it? It's a lighter gas. It helps to rise. Got it? So hence it is used for meteorological purposes, we can say that. It is used to fill up the gas balloons along with helium, we can say. So that is these are the uses of hydrogen, so to say. Hydrogen can be used, but hydrogen that is, as I said, it can be used as a fuel. Why it is used as a fuel? Because hydrogen generated engines are what you can say non-polluting. It produces more energy per gram of other fuels, convention fuels like petrol, diesel and all. It produces more energy, we can say that. Alright, hydrogenated engines. Of course, that has not come to the market because a lot of disadvantages is there, because it is costlier, that particular one is. It is difficult to store and transport hydrogen because hydrogen is highly inflammable, we can say that. Got it? So in this way, it has not come up to the market. Still, it is in the research stage. But hydrogen at all, if it is used, then it is non-polluting. It produces more energy compared to the conventional fuel like petrol, diesel and all, we can say that. But as I said, it is relatively costlier, it is difficult to store, it is difficult to transport, it is having low density, it is not portable, it is highly inflammable. For all these reasons, it is not used. Still, it is in the research stage, we can say that. So this is all about your hydrogen. Thank you.